Cool. And in this video, we're just going to quickly look at Sparse PCA. So Sparse PCA, for our normal PCA that we're doing, PCA looks at all the features, all the features, and then creates the linear combinations and stuff like that, like we did in one of the previous videos, right? But for Sparse PCA, it doesn't use all of the features. It doesn't use all of the features. It retains what is called a degree of sparsity. It chooses a certain number of features. Instead of using all 784, it might only use, let's say 500 of the features to do PCA. So this is controlled by this component called alpha. No, not the component. This hyperparameter called alpha. The Sparse PCA, it searches for linear combinations in just some of the input variables, not all of them, some of them. Because for our PCA, we do it for all of them, the linear combinations of all of them. But with Sparse PCA, it does some, and the number that you're going to use is controlled by this alpha. And what that does is it reduces the original feature space to some degree, but not as compactly as our normal PCA. It just reduces to some degree because we are not doing it like as densely as we do our normal PCA. And this is just the code of how to do it. It's pretty much the same. Excuse me. It's pretty much the same. The only difference here. Let me move my chair a bit. The only difference here is this part here, and this part is not necessary for you to run Sparse PCA. We just did it because this runs very, very slowly, because it has to choose the ones that it has to choose the sparseness and how you want which features to use and stuff like that to maintain the sparseness. PCA would have just gone straight without worrying about, oh no, but I'm not supposed to use all features. It would have just gone straight. But this one has to worry that it doesn't need to use all features, and it has to observe this alpha. So it runs very slowly, and just for demonstration, we trained it on just the first 10,000 instances in X-Train. Just the first 10,000 instances in X-Train. And this is the result of the first vector and the second vector. Not as magnificent as PCA, but you can see that it is doing well. It's actually doing well. The zeros are here, the nines are there, the ones. You see? So even Sparse PCA, just trained on the first 10,000, is doing well. It is doing well. I think you can confirm that it is doing well, even with its sparseness of 0.01. So you can play around when you get this notebook. Play around with this 0.01, see the effect. See the effect. Change this around to 10, 100, 10,000 and stuff like that, and see the difference. Just make sure that you have a powerful enough computer. If you don't have a powerful enough computer, try do it on, let's say, like Google Cloud. Google Cloud is like free computers that you can use that are extremely powerful. So yeah, you can do it there. This is what I wanted to just tell you about Sparse PCA.